Hello, my name is Lucas Eichmeier, and in this part of Solar Fundamentals we're going to speak about how to collect solar radiation. The intensity of radiation which is incident on a surface is dependent on the relative position of the surface with respect to the Sun. The position of a surface can be described with two angles. We have the surface slope angle, which is the angle between the normal angle of the surface and the zenith. Then we have the surface azimuth angle, which is the angle between the surface normal and due south in clockwise direction. In order to determine the radiant flux which is incident on the surface, we need to calculate the incidence angle, which describes now the relative position of the surface with respect to the Sun. The incidence angle can be calculated with this equation, where the different variables are the surface slope angle, the surface azimuth angle, the solar zenith angle, and the solar azimuth angle. Knowing the relative position of the collecting surface is very important, as the incidence radiation on the surface will change or will decrease if the solar beam radiation does not impinge normally onto the surface. This effect can be described or can be calculated using a simple conservation of energy balance. It can be seen that the interception area AC is increased by the inverse of the cosine of the incidence angle. Thus, the surface intensity decreases because, of course, the total energy has to stay constant. The effect that the surface intensity IC decreases compared to the beam radiation IB, depending on the incidence angle, is described by the so-called cosine effectiveness. For the simple example of a horizontal surface, the incidence angle is equal to the zenith angle. We already know that the zenith angle depends on the latitude, the day of the year, and also the time of the day. Therefore, we are able to plot the cosine effectiveness in a graphical way as a function of the time of the year and the time of the day. This is very similar to solar position maps. In this video now, we can see the change in cosine effectiveness as a function of the latitude. As you can see, the cosine effectiveness is highly dependent on the latitude. In order to increase the effectiveness of solar collection, we need to position the solar collecting surface in a certain way. For non-tracking surfaces, it is important to know the surface slope angle and the surface azimuth angle. For a non-tracking surface, the most efficient angle of the azimuth angle of the surface is 0 degrees. That means the surface is pointed due south. The surface slope angle of the surface is a bit more tricky to determine. In this video, we're going to see the cosine effectiveness for a fixed latitude, but for changing slope angles of the surface. We can again see that the cosine effectiveness, this time for latitude of about 34 degrees, somewhere in Italy, changes quite dramatically with the different slope angles. For maximizing the total energy gain of the collecting surface, on the northern hemisphere, we position the solar collector due south, so an azimuth angle of 0 degrees and a slope angle which equals the latitude. This yields the highest energy output over an entire year. However, it is also important to point out that this optimum or this maximum does not take into account a number of factors. It does not account for local shadowing or blocking. It does not account for the energy demand curves. And it also does not account for local climates. What I want to say in conclusion is that each situation is individual and each design of a solar power plant requires a specific design. As a next step, we're going to calculate the cosine effectiveness of a solar collector placed in Stockholm, same day as we had before, the 26th of July, at a clock time of 15:45. We already know that the solar zenith angle at this position at the time of the year and time of the day is 50.2 degrees, and the azimuth angle is 56.1 degrees. I recommend you now to stop the video for a few minutes, calculate the cosine effectiveness yourself, and I'm going to show you the results in a second. For a tilted surface, which has a slope angle of 59.3 degrees, which equals the latitude, and an azimuth angle of 0 degrees, we can use the equation which I've shown before for the incidence angle and calculate it to be about 46 degrees. Using the incidence angle, we can easily calculate the cosine effectiveness to be about 69.5%. For a non-tilted surface, so a surface which lies horizontally on the ground, the cosine effectiveness is a bit lower, it's only 64%. Thank you very much. This was Solar Fundamentals about how to collect solar radiation.